Hello, everyone. Thanks for joining us. My name is Irene Zhen. I'm the marketing lead for Juniper's SP and cloud security portfolio. I'm joined by Albert Liu.
I'm Albert Liu. I'm the Director of Product Management for Service Provider Security Solutions at Juniper Networks.
And the topic that we're going to cover is modernizing 5G infrastructure security. I think everyone listening to this session probably already see that 5G is happening across different countries, that their 5G is start rolling out in different level. And I think the other thing that all of us would agree is the promise of 5G is big. It has the promise of enabling new services, new use cases, and even new business models. And those are all very, very exciting. Now, with the speed, with the use case, with the new services, part of it is there's a lot of things going on with the infrastructure, the architecture, whether it is the speed, whether it is the architecture design. And with that, it also opens up a lot of the attack services. And that is something that the point of view that we are saying here is it needs to be addressed. Yes, 3GPP has done a lot of great work and provide a lot of guidance. And I believe most of the service providers are looking to 3GPP as the standard and as they rolling out their 5G infrastructure. But one of the things is that those guidance are guidance. Those are not mandatory. So that means it's still up to the different service providers in different countries to decide whether to take it or not, and also which technology they actually would use to implement. And so that could potentially create certain risks and gaps. And if we think about for 5G, part of it with the increased bandwidth and also the rise of IoT, that creates incredible opportunity for the hackers, whether it's the bandwidth that they have more capacity to launch attacks, or whether it's new architecture with the new interfaces that they can utilize to attack, or whether it's those millions to billions of the IoT devices that are fundamentally insecure. So that is why security needs to be really, really well considered from day one instead of as an afterthought. Now, here you can see that this is the forecast from the mobile data traffic. And what is very predictable is the 5G traffic will start coming in by starting this year, 2020, and it will continue to increase. But what we do predict is for a long, long time, it's going to be a mix of 4G and 5G traffic. And that means that when we look at the network, it's going to be coexist for a long time. And when you design the security architecture, the policy, what kind of policy that you're going to use to mitigate threats and attacks. And a very important design principle is to making sure that the policy is consistent across, and also whether it's for physical, virtual, or containerized environment. And also another thing that is important is as it evolved, then the architecture evolved from more centralized to distributed. But it's not going to be an either or. It's going to be a both and for a long time as a hybrid architecture across different regions. So that is another thing that as you design, the security needs to be compatible and consistent across the network infrastructure. This is the performance numbers that we get as we engage with our customers, and this is their forecast. While different operators' number in different countries will vary, but a consistent trend that we see is that the traffic, the performance, whether it's throughput, whether it's the connection scale, is expected to double every 18 to 24 months. So the question is, as this is the trend, then how do you gonna modernize your security infrastructure to make sure that you can keep up with this space, keep up with the demand from the customer, whether they are consumers or enterprises or governments. And in addition to the performance and scale, another aspect that is new to 5G is the adoption of edge computing. So the idea of having the cloud technology instead of having it stay in the centralized data centers, centralized architecture, but instead moving it to the edge, to be more distributed, to get it closer to where the data is generated, to get closer with where the end consumers are, be it human or devices. And so this is generally agreed that the edge computing is a driver, is an enabler for really enabling and fulfilling the promises of 5G. So those are great. The problem, though, that it also brings is that as you have those distributed places where historically those are the locations, whether it's central office or regional office, is used to pass data. It was not intended to be using as data processing facility or mini data center. So now as service providers evolving those locations into edge computing facilities or edge cloud, then security also needs to be deployed there. Otherwise, what if some of the facilities, those small facilities that don't even have staff there? And if no security there, what if somebody hacked one of those small locations or facility and then use it as a way to get through the central system and attack the full infrastructure? The impact will be really disaster. And so that is why it's important to think about it. But of course, from a very practical standpoint, having distributed approach on a design standpoint, it makes sense. When it comes to actual implementation, there's a lot of consideration. The cost, the facility at those locations usually are much smaller versus the big data center. So how to make sure to balance those things, and also managing multiple, let's say a couple big gigantic appliances is one thing, but managing tens, hundreds of those small security devices, the operations challenge is another very practical issue or practical challenge that service providers, especially the infrastructure and operations team, will need to tackle. Another thing that is relatively new, it's not new for cloud providers, but the adoption of virtualization technology is relatively new for most service providers. And the idea that if the 5G that can enable multiple service cost efficiently is assuming that it's going to share the physical infrastructure and have different services using the shared infrastructure, but tailored to different parameters that address different needs for different segments. Maybe it's one slice, network slicing is the name of the technology, that one slice for maybe IoT, one slice maybe for connected vehicle, one slice for connected health, and one slice for general consumer broadband. So these different slices or different segment or use cases have very, very different characteristics and requirements. And some would need more security than the others. You can't put the same level of security to every segment because there's resource constraint for especially certain slices or certain use cases. And so the question then becomes, well, what if I were a hacker? What if I can aim to attack the lower security slide? Maybe it's a slide for massive IoT. And if I can compromise to get access to it and compromise also the higher security slice, what if I can do it? To prevent that require really strict and well-designed logical separation and isolation. And that is something that as service providers continue to invest in this domain, in this area, this is something that when you evaluate vendors, definitely need to make sure that those are well articulated and in their documentation and the architecture design, so that the risk of the cross-slide compromise can be mitigated. And then also, it's not just the slides, but also the orchestration layer, secure access, things like authentication. Those are the things that absolutely needed. But it's also worthwhile to invest if there's any other potential attack vectors that hackers can utilize. Because if they can compromise the orchestration and management layer, then the infrastructure and applications and the user privacy, those could be at risk. So that is why it's very important to evaluate all the vulnerabilities that evolve from adopting virtualization technology and have a plan to really mitigate those risks. With that, I'll hand it over to Albert to talk about Juniper Connected Security and how that can help you mitigate those risks and address the 5G security challenges.
Thanks, Irene. So you've described some very daunting challenges for 5G security. And as we look at the approach for addressing these challenges, we have to think about where we've been in order to understand where we need to go forwards. And the goal of Juniper Connected Security is simply to extend security to all points of connection across the network. It's important to safeguard users, their applications, and the infrastructure. And I think that you've seen that in what Irene has presented so far. In order to do that, we employ three broad approaches. One is a sophisticated threat detection engine. This is necessary to perform at scale and with very high throughput because we're going to see massive numbers of devices in some parts of the 5G network, as well as a massive increase in throughput from ultra mobile broadband. In addition, we're going to need to have centralized policy, management, and analytics, a clear view into what security policies are being implemented, which policies are actually being hit, and understanding what kinds of threats are present in the network is absolutely essential. Being able to orchestrate and manage your response is the third pillar of Juniper Connected Security. We can no longer rely on pure security play offerings such as firewalls to protect the network. They cannot economically and cost effectively protect the network from all different types of threats. We need to engage the entire capability of the network as a muscle in order to both identify and stop threats. So what does our 5G security architecture look like as we evolve from 4G? We have the 4G picture on the top part of this diagram. And as you can see, it includes base stations, a centralized security gateway, roaming firewalls for connectivity to other mobile service providers, and then a GI firewall with CGNAT and DDoS protection to connect to the internet, as well as microservices applications like IMS, voice over LTE. As we move to 5G, the first change is going to be that we're going to see an increase in the number of base stations. These base stations will need to have communication directly with one another for cost-effective handover and to support many more devices. To support this, we're going to be evolving centralized security gateways, which today are primarily physical appliances, into distributed security gateways that will support larger numbers of devices like the 5G G-Node Bs, in addition to high performance base stations, which will be terminated at the centralized security gateway. So in addition to these new distribution of security gateways, we're going to see that there will be at the edge cloud that Irene mentioned, a virtual firewall. So the security gateway that's in the distributed site here will not only be used for doing encryption and re-encryption of control plane information for base stations, so improved handoffs can happen and more devices can be supported, but also to be able to peek into the network, we're going to need to unravel the encrypted traffic that's coming from these 5G base stations with the distributed security gateway. And then at that edge cloud, the virtual N6 firewall will be able to analyze traffic and even be able to look at encrypted traffic without de-encrypting it through machine learning to be able to identify threats and stop them at the edge of the network. Then as we look towards the 5G core network, we're going to see that it is going to be deployed as a distributed micro-segmented architecture. And inside that application, that distributed application, we will see firewalls that are protecting both access rights, which will be important as the network scales up and down, as well as stopping the lateral threats that could be propagated between virtual machines or containers in the 5G core network. And then as we exit the 5G core network, we're going to see a new roaming architecture for 5G to 5G cores, which will include the secure edge protection proxy for protecting signaling between 5G networks, as well as the IP user plane security that protects the bearer plane between 5G networks. And then finally, we'll see a virtualized or containerized scale out or service mesh architecture for N6 firewalls, which is the evolution of GI firewalls, which will continue to perform stateful firewall and CGNAT functions. And we will see an even greater need for multi-terabit DDoS protection. So what do we mean by the power of a threat-aware network? What we mean is that with 5G, we're going to need to employ many different types of tools to be able to secure the network. We're going to have to be able to identify zero-day attacks that might be advanced threats. They may be zero-day DDoS attacks. There may be attacks that we see that are happening at the edges of the network. These attacks may happen at the core of the network. In all these cases, we need to be able to leverage the entire network, ranging from endpoints to switching to routers to security appliances, to be able to detect and coordinate a response to a threat. These products must be available in both virtual form factors for ease of deployment and speed of deployment, as well as physical form factors for very high performance. And they all must work together and have a consistent set of policies that can be orchestrated from a single place with Juniper's policy enforcer, which includes security intelligence, automation, and orchestration. So all these tools must be brought to bear for a complete solution. It's no longer sufficient to have a set of point solutions that provide a disjointed response, as we've done in the past when dealing with 4G security. One of the new technologies that Juniper is pioneering is what we call encrypted traffic analysis. Instead of taking on the daunting task, which requires a huge amount of compute, which virtualized and containerized offerings are really not well equipped to perform, of trying to encrypt and decrypt all encrypted traffic to analyze its potential threat, our encrypted traffic analysis is able to, at scale and at very high speed, ascertain whether connections between devices, as well as between network infrastructure pieces, are actually threats. For instance, we may be concerned that firewalls in the core of the 5G network are under attack in their administrative plane. How would we actually know that? We do not have the time or the computing resources available in an economic fashion to determine whether our attackers could be at work trying to disrupt the infrastructure. With encrypted traffic analysis, we offer a different approach based on machine learning that does not require encryption and decryption of the traffic. The way this works is as the TLS handshakes or SSL handshakes are established, metadata is analyzed by the machine learning engine, and it is determined whether or not either device at either end of that connection has the potential to be a threat. If it is a threat, we can then take an orchestrated and measured response that is predetermined by the network administrators to be able to stop the threat, look at it some more, or at least flag it for further identification and analytics. And then I'm going to wrap up here with talking about the increasing amount of DDoS attacks that we're seeing at our service provider networks. We have seen attacks that will sweep across the entire population of mobile endpoints at a service provider in a matter of less than 3 minutes. In that time, they are scanning for vulnerabilities while also attempting to disrupt the networks. Traditional approaches do not have the continuous monitoring that is required to be able to respond to these attacks. Typically, it can be up to 5 minutes to 15 minutes before a traditional DDoS mechanism is able to actually identify a high-scale DDoS attack. During this time, you run the risk of having the attack take down the network and not being able to respond. to the attack that's actually underway. With Corero and Juniper MX Edge routers, we are able to deliver a sub 15-second time from detection to stopping of the threat, and also to scale that performance to 40 terabits or more. And we're able to do that without any decrease in the quality of service that has been carefully engineered into the service provider network. The way this works is that we are able to take information directly from the network with the Juniper Edge routers, feed it to the Corero SmartWall TDD, which then performs analysis on potential attacks underway, including multi-pronged attacks. So there could be an attack with multiple different vectors of DDoS, and to be able to then reprogram the same MX Edge routers to stop the threat right there at the edge of the network. We can do this at line rate without requiring an external scrubbing center. So not only are the economics of this much lower from a CapEx standpoint, but perhaps more importantly, it is fully automated. So the team of advanced network engineers that are required to operate a scrubbing center for traditional DDoS solutions is not required. Instead, we can automatically protect the service provider's 5G network from very, very large-scale, short-lived DDoS attacks with a high degree of confidence of being able to identify the attack and stop it. And furthermore, once the attack is over, to release the controls that were in place to be able to stop the attack, thereby allowing the network to run to its full potential.
And so I hope you enjoyed this session, and a couple of key takeaways that we would love to have you take it. So first is 5G rollouts are here, and security is more important than ever. Whether it's enterprise, whether it's consumers, whether it's governments, they all anticipate and expect that with a newer generation of the mobile network, it needs to be even more secure. Secondly, is we see the trend of the convergence of networking and security, and that is the principle that how Juniper Connected Security is built on. And what we believe in is security needs to be baked in and distributed across the network and integrate with the network. To prepare your infrastructure ready for 5G, especially the security infrastructure, higher performance and scale, security intelligence, and security automations are essential capabilities to have to get it ready. Thank you for joining us today. If you want to learn more, reach out to your account manager to schedule some time with us to discuss more.